All right, I think I figured this out. I had to go through like a whole bunch of two-party verification through Google and a whole laundry list of stuff. So definitely interesting trying to get this thing to actually work with different software to, to connect into Face or into YouTube and all that stuff. But looks like I figured it out. All right. So, hey Brooks, can you hear me? Let's see. All right, that's perfect. All right, I'm gonna get this out of the way. I'm not really savvy on streaming. This will be my first actual stream. So we'll see how this thing actually works. All right, perfect. All right. So yeah, no, this is I figured today was probably be the best day just to experiment with this stuff, see if it's actually possible. Um, I had to go through some third-party software to get the stream to work. I'm probably going to reach out to Mark, and I know he developed some software, and I'll reach out to him and see what the best options are for this because the way he runs his stream is it's actually really good. Um, but so with this, it's just open questions or anything that's going on with Erickson Design. We're working the YouTube channel, different projects that I got upcoming. Actually, got a lot, and then the like the 2.5 month hiatus that I've been on uh, for man, I haven't posted a video for almost 2.5 months. And so yeah, we'll get it. So if you have any questions at all, I'm gonna go ahead and I'm gonna pull up Fusion 360 and I'll start sharing some stuff that I've been working on. I've been experimenting with different puzzles, and I got a whole bunch of different sets, different tolerances between the different pizzas, whole laundry list of stuff. So still kind of working out the fit, but eventually, what I'm going to do is I'm going to build all these different contours in and a whole different bunch of profiles. But what I want to do is have a puzzle piece that is, a 3D object. And technically, this is, but I want it to bear its weight and hold itself together within these joints to make a 3D object. And that object can be suspended in air where the tolerances are so tight that it will keep the puzzle pieces locked in. And I've been experimenting with different, techniques with that. And I don't know, I haven't actually made it yet. So just experimenting with the tolerances to see if it's actually possible has been a pretty good challenge. And dialing in those tolerances have been quite interesting. I've done a couple test pieces, and if you make it too loose, like it just kind of folds in on each other and it just all collapses. But I think eventually I can get that to the point where it's actually pretty good. No, they're not dovetail fingers. These are just like normal puzzle piece, you know, finger joints, basically. And you have a male and a female. And depending on the puzzle piece, whether the other piece on the other side will actually interlock. Um, but I'll pull up some CAD drawings so you can visualize some of this stuff. I haven't built the 3D object that I want, where it's suspended in air. I'm gonna try to build that today, or at least design it. That way, over the week, I can actually get in the garage, work with some material, and actually see if I can actually make it come out, which is cool. And let's see, let me pull up Fusion, and I'll give you some of the current drawings that I've been doing. Let's see. I want to make sure I do the screen so you can actually see my workflows. Yeah, this will work. All right. So hopefully you can see Fusion 360. And actually, I'm going to make it. All right. Yeah, let's get this thing up. Sorry, it's my computer was lagging pretty good when I started up Fusion. So my next video, it's going to be like an easy to medium to hard CNC project. So the easy CNC project is just going to be a very simple 3D puzzle design, and um, we'll pull these in. So just making the actual puzzle pieces, looking at the tolerances to actually make each puzzle piece configured correctly to actually make. And then I'll probably just put like a simple, maybe I'll use my laser where I can do just a simple design on top, maybe my company logo, um, which would be pretty cool. And so that's the easy one. And there's not a whole lot, to the file. I think any kind of basic, CNC woodworker can make this and be overall pretty successful on it. What I'm going to end up doing is take that a step further, and I'll pull up the next step. And this one is just adding a texture, and that would that would require a ball nose uh, texturing bit, 3D bit, and to put these really cool honeycombs in the actual design. Still the base puzzles from the previous design, and then working into something more complex is adding that profile to it, and then all the steps that are required to that. I don't know, Cosmin. I don't know if I haven't got rich yet. Matter of fact, I don't sell anything at craft shows, and so I couldn't tell you what that market is. But a lot of things that I make, people reach out, and it does sell pretty well. And depending on the material and how complex everything was, whether it was inlays, epoxy, different types of mediums, those prices increase significantly. And if you have a very fine niche in that space, I mean, you can basically name your price, and some people will definitely pay it. You just got to find the right audience with the right budget. So this is technically the medium, semi-medium. I'm probably going to do 4 or 5 different ones, and this is still a puzzle. Um, the puzzle pieces are still the same, but when I cut the profile in, it's going to be this, and it's just a very simple honeycomb where it just dips in. And in the manufacturer portion, I ended up doing something pretty cool where I ended up taking a V carve along these lines, and I added some depth to it. So it kind of broke up the 3D surface, and V carving those lines really did a good job of defining those honeycombs. I thought that was a pretty cool feature. Matter of fact, we can we'll simulate this, and you can see, and the depth that this thing is cutting isn't very much, which is pretty cool. So you can paint these if you're using different, say you're using a very light colored cherry or maple. When you paint these lines into this, it does a really good job of defining that space, and it just breaks everything up. If you ever seen the space ball thing that I did maybe a couple months ago, adding those black lines really defined everything pretty well. So I thought that was a pretty cool feature. Um, Let me make sure this actually has the profile cut into it. Let's bring this back up. So you can see this is a 3D ball nose tool path, and it cuts that in. It does a really good job of it. And I think the overall depth of each one of these honeycombs is probably about like a half of an inch. So when it goes down, it really does do a pretty good job of it. Um, and then just following up with that V carve along those lines, like it really does a good job. But so that's the progress. So something very simple of, just cutting these puzzle pieces out, and then additional operations to set this back in the machine and start machining some really cool 3D contours and different surfaces. Um, you could put it in a laser engraver also, and basically laser engrave anything that's over on top of it. And it just adds more depth, adds more customization, and these things actually really do sell pretty well. So yeah, so that's one of the next steps. The the step above that would be, let's pull this up. So this is a more defined honeycomb, and it has a very defined 3D surface where it's really wavy. I ended up following the wave of the honeycomb pattern that I have with the dimples for and how the dimples go on the surface. So again, all of these are additionally within the CNC to make that a reality. So really defined, very, very wavy, and this is going to take some pretty cool. It's going to take a while for this to machine, but you can see the honeycombs follow that 3D surface. And I thought that was actually a really cool, feature of doing that. And again, these are all 3D. These are all puzzle pieces. So I'll pull one out, and you can see the definition of this puzzle piece when somebody puts this thing together. It is very unique. And those black lines you see there, right? That's the V carve of defining that portion of that honeycomb. If I didn't have this in here, like it would be hard to distinguish how that actually lays in. So again, those little details really kind of really defines it. But yeah, so that's that 3D portion of that puzzle piece. And it's just a build on. So if you can get through the simple portion of just cutting out the puzzle pieces and then getting into the more advanced steps with uh, different types of bits and operations tool paths for the CNC, I mean it's almost endless on the possibilities of defining that piece to the overall structure that you want. I did a couple more 3D designs. I did one. We'll do ended up doing a star version of this, and yeah, we'll see if this pulls up. Right, so you can see the puzzle pieces, and this is a round puzzle piece, and what ends up happening is this builds a kind of a tray, and these trays are, I want to say, about 7 inches in diameter, so it's actually pretty robust, and I hope that this star pattern will come out pretty well. So I'll put the puzzle pieces back in, and then let's change this up so you can see the definition of that star. And again, these are all puzzle pieces that are putting this thing together. So if I wanted to move a middle piece, you can see how all of that interlinks together. And what's nice when you're using Fusion 360 to build some of this stuff, you can see that the toolpath generations, you get a really good idea of what the final outcome is going to be. So you can visualize different woods, different types of coloration that you want to put into it, and you can build a really good picture in final end state that before you can even step in the garage to realize what it's going to actually be. So it's pretty cool. So over the last 2 months, that's kind of what I've been working on. I haven't been posting a lot of pictures. I haven't been in the garage for a really long time. And this week, I'm going to go ahead and do a video on the step by steps and then the progress from from easy, medium, and hard projects for the CNC. So that's where I'm at. It's kind of a pretty good overview of what's going on. I'm probably going to get into the today on actually drawing a more 3D pattern, kind of a dish puzzle, kind of like the warped space theme that I did, and start working through the design process and make that a reality. So if you guys want to stay for it, if you guys want to ask questions, great. That's the whole purpose of the live stream. And I'm probably going to jump into Fusion and actually start making this. Pretty good. It's something that I've been waiting to do for a while now. So let's put this back in. And but yeah, endless possibilities when different designs. So let's go back. So I'll kind of work through the workflow that I did for all these iterations, and what I ended up doing, I started with this. So I'm going to go ahead and just save as, and then I'm going to do this as a 3D warp puzzle. Let's do space warp. I think I'm going to keep the space theme. So to give you guys an idea of the space theme that I've been kind of doing it, that was one of my last videos that I did, and let's do. Yeah, it's going to be this one. I'm going to remake this because I ended up running into some issues with the material that I wanted to use, and the bit that I was going to select to actually make this thing a reality. Let's see if this is actually it. Yeah. Yep. So I'm going to make this today. I'm going to CAD this out exactly how this is. And you can see that it has some pretty cool features. I'm going to cut this into this base of this walnut, and these pillars are going to hold this thing up. But as you put the puzzle together, this is a puzzle piece, the base is a puzzle piece, and then these are all individual puzzle pieces. And let me pull this one out. Yeah, they're not grouped. It's okay. Let's do this. Yeah. So very basic. I'm going to cut a little dip into the wood. That way, when you assemble the puzzle pieces, the first 4 pieces that you assemble will go right into the box, right into the base. The pegs will get inserted, and then you'll eventually just go ahead and start making this. So actually, yeah, we can, let me hide all these. So you can see how each puzzle piece fits, and they're all suspended. So like that's a pretty good radius of a piece, this piece right here. And they're very, very unique. And the tolerances, when they connect to themselves, will eventually hold everything together, which will be pretty neat if I can actually get it to work. So, but I'm going to redesign this because what I ended up doing is these are individual bodies of these lines. I don't want to do that. Originally, I was going to just make the best way to explain it is making a end grain cutting board. And then when you cut them, you can insert veneer strips to get those really fine lines, and they'll go all the way through the material. With this project, I'm only going to V-carve these black lines. So it's just going to be one solid block of wood that I cut each puzzle piece out of. And then those puzzle pieces will get V-carved for those lines. It's a lot easier, a lot faster. You could still glue everything up and put the veneer lines in. Um, but again, that's pretty time consuming, and that's something I didn't want to do. I already did it once, and it was pretty labor intensive. Okay, so I'm gonna go ahead and I'm gonna hide all this, exit out of this. I'm not gonna save anything, but what I'm going to do is I'm gonna use this file. I'm gonna save as, and then I'm gonna put this in my puzzle folder, and this is gonna be the 3D space warp puzzle. So let's save as there. And then I'm going to delete. I'm going to keep that. I'm going to go back to my original sketch. And these are the puzzle pieces that are put together. To get this, when I extruded it, I just moved those pieces away. So that way I could have enough room for my bit to go through. I don't need that right now. I'm going to save that because I'll use that as cut files for later. But let's go ahead and we'll extrude all these to, we're going to go 1.75. And more than likely, I'm going to use, this block of cherry to cut all the pieces out. Right now, this is planed to 1.75 inches. And let me get my calipers. Let's see. Yeah, it's right at inch and 3/4. So this is my base material that I know that I have. I'm probably going to flatten it just to make sure everything is extremely flat. But yeah, so the end state is to get these to 1.75 inches. So I'm going to extrude all of these and get the overall all depth of it. Actually, let's do this. So these are 1.75. And I'm going to do a new body. That way it doesn't pull everything together. And then I'm going to right click and hit repeat extrude. And I'm going to do that for all of these. And I'm going to copy this, and so that way I can paste. Saying it's not wanting to go for me. Oh, you. Repeat. I just got to make sure every one of these are brand new bodies instead of joining them with the other two. And then I'll come over, right click, repeat extrude, new body, repeat, new body. And last one. Okay. So completed puzzle with all the pieces is going to be, I forgot to mention this, that the square that I did was 6.5 inches by 6.5 inches by 1.75 inches depth. So now what I can do is I can manipulate these to where if I need to cut them out, I can move them, however much distance I need to allow enough room for my bit to come through. That's why I saved uh, this other file or these other bodies. But what I want to do is I want to use this as a base to cut a 3D profile into. And so with that, I'm going to go ahead and make that 3D profile. And what I want to do is, make it like that warped space, the space time holder that I did. And so to do that, let's go ahead and we'll hide these bodies. I'm going to hide this sketch. And I'm going to draw on the bottom plane a new square. And I'm going to use the 6.5 by 6.5 square so I keep everything symmetrical. I'm going to extrude that by 1.25 inches or 3/4. Let me hide these. Now, since I've made all these bodies, I'm going to go ahead and just make a new folder in this folder, a new group. I'm going to call these new puzzle pieces. And then I'm going to dump all these in there. And what that does is it really does clean everything up. So I can see all my puzzle pieces after I unhide everything. I'm going to hide that. I'm going to bring this body back in. And I'm going to go ahead and I'm going to create a form off this. So I already have known goods. And I can build a plane off of this box of these dimensions. So I'm going to go up here and click 2-point. And I'm going to select this point, this plane, and then this point to this point. And when I'm building a form, I like to keep the number of intersections very, very small. So I'm going to hit OK on that, and then I'm going to bring this down. And that will give me that space-time scene that I want. But I don't want to go, I don't want to bust through this because that's the material that I'm working with. Let's go back here. So I'm barely going to go to the bottom of this thing. And this will dictate how thick my actual material actually is. Let's go right about there. Yeah, I like that. So that's the profile that I want, which is actually pretty cool. I'm going to cut this into those puzzle pieces and it'll give me that profile that I'm really looking for. But before I do that, I want to add thickness to this. Thickness of the materials, I'm shooting for at least 1/2 inch of the thickness of this plane. So I'm going to go to modify and I'm going to thicken. And I'm going to come down 0.25. We're going to come down 0.5. And I'm going to keep that sharp. Direction is normal. So now it thickened everything. And that's what I'm going to shoot for. Now, did I bust? Which I did. So I'm going to have to come back up. And I'm going to use my wireframe on this because now I have 2 points. The thickness here and the top portion here. And that's the same for the bottom. So if I want to bring this up, I got to do the top portion and I got to do the bottom portion of it. So let's go ahead and move. We'll edit form. I'm going to select this top portion, this point right here. And then I'm going to select this top portion or this bottom portion. So now when I move, all of that will move as one. And we'll bring this just up just a little bit. I like it. Now I left a little space at the bottom because I'm going to move this down just a little bit. And that's the profile, and I think that actually looks pretty good. Now what I can do is I can make this a little skinnier by taking this top portion and just bringing it down a little bit closer to the bottom. Essentially just kind of thinning it out. So let's bring this down just a little bit. I like it. Okay, so let's do a wireframe and I'll show you what I meant by that. So you have the 3D portion of this. This is 0.5 thickness. And then when you get down here, it kind of stretched down. When it stretched down, it went a little thinner at the bottom. And that is consistent with if you had a heavy object on a piece of cloth or material that, you know, if it had enough weight that it would stretch downwards. Um, I think that's actually pretty neat to build that into that overall model. And you'll see it on the puzzle pieces to where the puzzle piece will be thicker on one side, and when it goes down, it will shrink. So that's actually a really cool little feature. All right, let's get out of the wireframe. And we're going to call that good. Now, I'm going to bring in my puzzle pieces. I have my overall mesh that we made. It's not really a mesh anymore. Since we added the thickness, it's actually a body. Let's go ahead and we're going to cut these into these pieces now. And what I'm going to do is I'm just going to bring this down like 0.05. Ever so slightly. Still within the puzzle pieces. Ooh, no, it's not. Let's go back. Well, let's see if it will actually cut it. All right, bodies to split. We're going to do this all the way down. And we're going to use this as a splicing tool. I'm going to extend it. And it looks like it worked. So it made, when it spliced everything, it made all of these bodies. So I'm going to go ahead and we're going to delete all these additional bodies that it made. All right, let's remove those. Then we'll bring these back. So that is all the puzzle pieces now with that profile. Pretty cool little trick because these are very complex in nature. So if I was to move this, that's what the overall puzzle piece will look like. Very unique, very slanted. And when I program the CNC to cut these out, I got to do it in a way that it actually is tight enough to hold itself together. They have to interlock and they have to bear its own weight. So if it's too loose, they won't do that. They won't bind just right to hold everything together. Um, and so we'll walk through what that actually looks like, and I think that actually looks pretty good. Let's do this side. Look at this one. What I'm also looking at is the overall thickness. So anything that's smaller than 0.25 will get brittle enough to break. So if you're trying to put everything together and you're just trying to assemble the puzzle, if it's smaller than 0.25 on one of those edges, there's a good probability that that thing's going to break. Uh, so adding an additional, eighth of an inch thickness, we're talking very small, dimensions here, but that thickness will give you more stability in the actual material, and so it won't chip as bad, or it won't have the ability to break when somebody actually tries to put this thing together. So it's definitely something to look at, and I don't see any other issues. Those should all be the same, as this is the lowest point indicator. So just having that 0.02 actually makes sense. So all right. So those actually look pretty good. So what I'm going to do now, I'm going to put these back. And then I'm going to have to put the holes in for the bottom of the base for the dowels to connect. But let's go ahead and build the actual base. So let's do that right now. So I'm going to start a new drawing. I already know that this thing is already centered in this plane, so I can click this bottom plane. And if it's 6.5, I like to have at least an inch to work with. So let's go ahead and go 7.5 by 7.5. Sync. That'll actually look pretty good. So that's the overhang, and I'll probably take a router and I'll route a profile along this edge, and that usually gives me about a half of an inch to work with. So it's actually cutting it pretty close to where that profile will be along that line. The only reason why that's important is when I determine where I want the holes. I got to make sure that it's actually not inside that profile on the outside. Okay, let's do this. So let's use the rectangle tool, and we'll find the overall dimension of that center point. Yeah, Brooks, the I want all the puzzle pieces and how they join together to be in the same grain uh, direction. So I'm going to keep it face grain, and I'm just going to have it move. I'm going to keep it where it goes from left to right. Um, and you can see that with this example. Um, And when somebody's putting the actual puzzle together, they'll know if they actually flip this thing up or have it on the wrong direction. So I don't know if they'll actually visualize that or understand that, but I want the grain to be face grain and left to right. I've had some issues with a couple. I did a puzzle that was end grained up, and I had issues with pieces breaking, just because the end grain was that direction was so weak. So it's definitely a concern. Yep. But if you use face grain and keep it left to right and have that consistent through all the puzzle pieces, you're good to go. All right. So let's drill these holes. Actually, let's just use the offset tool. So we'll offset this outline. We'll come down. I'm going to unhide this so I can see where I'm at. That's pretty close. Just call it 1.25. So an inch and an eighth inwards. And that gives me pretty close to the outside edge. It gives me enough room for the outside portion. So let me hit OK on that. I'm going to unhide all these bodies, and then I'm going to drill. I'm going to create circles for the dowels. Dowels actually measure pretty close to 3/8. I find that if you go 0.38, those dowels fit pretty perfect. Actually, I'm going to go just a little bit more. So 0.385 gives me enough tolerance to when the dowels go into it, I don't have to like force them in. They can actually just, finger pressure and they'll go down into it. And that's just because I understand that because of these things. So the CubeSats, these holes that I drill on the exoskeleton of these things are 0.38. And when I put this in, like it's pretty tight. And when somebody is working with a puzzle, if they got to force anything into anything, it's probably not going to last, and they're going to break something. So if you add just a little bit of tolerance addition to it, it actually fits pretty user friendly, and you won't have somebody trying to bind something in or end up breaking the piece overall. Let's see. I've learned that the hard way. So just adding that additional 0.005 pays some dividends. Let's just say that. So let's do 0.385. And we'll do another one. And I can actually just do this, and I'll just constrain. So this will equal this. This will equal this. Exit out of that. And then I can basically, I'll just delete these lines now. Okay. So that's my base drawing. I'm not going to put anything else into it other than all these bodies, and cut it into that actual base material. So I'm going to finish this sketch, and then I'm going to extrude this downwards. And I deal with 1/4 inch material. So say this is Purple Heart. This was like rough lumber. And then what I'll do is I'll plane it. So 1/4 is just under an inch when you buy it at the lumber store. And I'll feed this thing through my planer, and I'll get it down to 0.75. I usually plane all my material to 0.75. It keeps it very easy to remember, especially if you're going to machine something and if I design everything to 0.75, I automatically know that I'm going to plane that to 0.75 or already have it planed. Okay, I'm going to bring that sketch back up. And that actually should have been a negative because I want that drawing on top. So I'm going to put this as a negative. So now I can see my drawing. I can actually drill these in. So I'll probably put these, since I'm at 0.75, I'll probably put them at a quarter as far as depth. And that should give me enough space for those dowels to stay in there. So we'll do that as a negative. Good. And then what I'm going to do is I'm going to pull all of these back up. So I'm going to get rid of this. Don't need that anymore. All right, I'm going to hide this sketch. And since I want this to be supported on this base material right here, I want the base to hold this together. So I'm going to take all of this stuff. I'm going to highlight all of it. And then I'm going to hit the move and copy. And I'm just going to bring this down. And I can see how far I'm going in. And it doesn't have to be far, but I want at least good contact in between each individual piece. So if that joint right here is about half, I'm comfortable with that. I'm hitting half that joint, and I'm basically hitting it on all sides. So I think that actually looks pretty good. And I think that's enough support. Okay, so I'm going to hit OK on that. And then what I'm going to do is I'm going to splice, or actually I'm going to cut. I'm going to combine. So in the combine tool, this is actually pretty cool. I'm going to use the cut feature in this. So the target body is my base. And sometimes this doesn't work. And so we'll see if there's another method if this doesn't actually work. And I'm going to cut that up. I'm going to use a cutting operation. And then the tool bodies is going to be this, everything that's on the bottom and touching it. So there's 4 pieces here that are touching that base. And then I want to keep my tool. So these bodies that I used to cut this to do the cut, if I don't click that, it's going to delete those. And it's only going to keep the bottom cut, and it's going to get rid of all this other stuff. But if I click that, it's going to keep that tool as, that is still valid. Okay, so I just hit OK on that. And now you can see that let's hide these puzzle pieces, and there's my circle that's 100% in the middle of everything where those need to be. Sorry, give me a second here. So I have my dowels. I have the comb, the radius here that I want the puzzle pieces to sit into. And now let's go ahead and let's do our dowels. So quickest way, click the inside of these. And I think it was a 1/4 inch deep. Let me, hold on. These are kind of froze up there for a second. I'm going to click the bottoms of these cutouts for the dowels. And then from the side view, since they're all selected, I'm going to pull these up. And I want to keep a good distance for these dowels so I can cut them all at the same length. To see inside here, I'm going to go down to my display settings, and I'm going to use shaded with hidden edges. So then I can actually see my dowels as I go through, and I can actually see where they're at. That actually didn't work very well. Let's use wireframe. Interesting. That's that's an error with Fusion. I should be able to see right through that. But if that bottom right here is 1.1, if I go to 0.125, it should be okay. Not a whole lot of space on that pocket, but at the end of the day, it should be fine. I wonder why that's not letting me see inside there. It's interesting. I should see that line come up, and I should see how far I could go up. Let's hit cancel on that. All right, let's bring my visuals back. Wireframe was hidden. That's probably why. Let's try this again. Let's bring these dowels back up. And then let's bring these all the way back up. I'm going to bring those visual. That's probably why they were joining. That's probably why it was doing that. So there we go. That's why I ended up having join, and when it joins, when it calculates it, it's not showing it because there's nothing there. New body shows me that I have this in. So 0.25, that's not a whole lot of space here. That's not a deep hole. So let's go to let's go 3/8. So 375. So the overall distance for these dowels will be 1 3/8 by 3/8. What I don't want to do is hit OK. Well, yeah, I can do that. Okay. Let me pull the visual settings. There's two ways you can do this. The one way is you can create the new bodies, and it won't account for this going into this piece. So they'll just be kind of merged together. To get around that, you could just go ahead and cut this and then do the operation again, and then make a new body, and it will fill that gap in. I'm going to go ahead and just do new body, and I'm going to cut these back into these 4 pieces. So let's go to visuals, and you can see that I created those dowels, and they're 1 3/8 that are going into that piece. But now I gotta cut this into this to give me that space. So when I do my tool pathing, it'll account for that, cut for the dowel. So I can do the combine tool again. I can select my target bodies. These are the 4 corners of this. And then oh, let's do this. Yeah. We'll do split. All right. We'll have to do it the other way. All right. Let's try this again. And this is the sometimes Fusion, the thought process on, yeah, this will work and I can use this operation to do another operation. Sometimes it just doesn't want to do it. And so you got to really experiment with Fusion on what you actually want to do and tell it to do. So let's go back here. This is going to be an 375. And then I'm going to go ahead and just cut that in. So what it's doing is it's cutting those 4 pieces, right? these 4 pieces are getting cut into these 4 pieces. So when I hit OK, now it has the holes that are pre-drilled into those bottom pieces. Now what I can do is I can go back to my extrude, come back here, select those holes. And I already know the distance of 1 inch and 3/8 is the overall length of the dowels. And I'll just go ahead and create new bodies and they'll sit right into it. So then this will be 1.375. And then instead of join, we want new bodies. And hit OK, and now I have my dowels. So now if I hide this, these are my dowels. They're exact locations on what my machining operations will be for that puzzle piece. And then my puzzle pieces are aligned correctly and have the correct holes drilled into them. So no matter what, when I do my dual-sided machining, I'm accounting for both sides, the top profile and bottom profile cut with the additional holes. That's all automatically programmed in. All right, so that is good to go. And my puzzle pieces are good to go. And now basically what I can do is I can start machining. Now, when I start my machining, I got to be I have to have a game plan. I have to have a strategy for my workflow and how I'm actually going to cut everything out and what Fusion needs to do this. Because I can automatically visualize. I'll set some appearances on this. Let's say that I want the base to be black, we'll say walnut. So let's do the base as walnut. My pegs will be probably cherry or maple. Pine actually looks like maple when you do the when you do the different textures and everything in Fusion 360. And then I'll probably do cherry for the actual puzzle pieces. So let's go ahead and we'll drop this down and I'm going to select all my bodies. And then I'm going to take cherry. I'm going to drag this over to all these bodies. Give it a second to think, and it should apply that texture to all the pieces. And Fusion, I don't like how that looks with the cherry. I'd have to go through here and edit all that crap. But let's just use maple. It gives it a lighter color. That looks better. Cool. Okay. So I have that. What I'm going to do now is I'm going to account for all the lines that I'm going to V-carve into this before I go into the machining ops. So to do this, I need to know where the top surface is to my plane. And then I have to draw the lines for the V-carve operation to follow it. So what I can do is I can do an offset plane. And this is all in preparation of drawing these lines. So I'm going to hide everything, get everything nice and clean. I'm going to select this bottom plane. And then I'm just going to drag this up. Right now, I'm just going to leave it there for right now. I'm going to bring in my puzzle pieces back in. And I want to make sure this plane is pretty close to the top. I don't want it below, and I don't want it too far up. I'm just going to put it in a place where I know it's above the working surface. So I'm going to hit OK on that. Now, what I'm going to do is I'm going to hide this. I'm going to create a new drawing. I'm going to select that plane that I just made. And it's already centered into everything, so I don't have to worry about anything getting crazy or misaligned or anything like that. Everything is bound into the center point. I'm going to use the rectangle tool, go in, and I'm going to build the outer box, which was 6.5 by 6.5. I'm going to hit OK on that. And then I'm going to draw a vertical line from the center point and a horizontal line from the center point. And then I'm going to use this really cool rectangular pattern feature. and I'm going to make a grid pattern, and I can select this other one too. So I have those 2 points, those 2 lines highlighted. I'm going to do equal spacing for my distribution, and I'm going to set that at 0.5. So every 0.5, there'll be a line. I'm going to do the same thing here. And then I'm going to do symmetrical for each one. And now it gives me 3 lines by 3 lines, which is the 3 lines by the 3 lines that are equally spaced, and they marry from the center point of that the original line that I put in. So now all I have to do is just start doing my quantities. And I want to say, I think it's 13. Yeah, it's 13 by 13 will give me the grid pattern needed to build that really cool thing. And I don't know why. I'm going to okay on that. I don't know why it got all crazy on me. Let's try that again. This. We'll do spacing. That's why. So technically, you should only do one line at a time. Don't click this other horizontal line. And then we'll do the same concept here. So let's do 0.5. Ended up just duplicating itself, and that's why it gave me so many additional iterations on the outside of that box. So symmetrical, we'll do a total of 13. I'm going to right click, and I'm going to repeat the rectangular pattern, and I'm going to select this horizontal line. I'm going to do the same thing. So we'll do 0.5, we'll do symmetrical, and then 13. Okay on that, and there's my grid pattern. Very fast, very effective, and they're all constrained. So I don't need this outside box anymore. I just made that just to make sure I'm within constraints of the profile that I want. And now it's good. So I can hit finish sketch, and when I look at it from the top, there's my grid pattern that I want to cut into. So my V-carve will follow these lines, and it will V-carve against this profile. Very, very easy. Okay, so I got that done. Now what we want to do is we want to figure out how we're actually going to make this, how we're going to do the machining operation. I don't need to account for any of these lines during my 3D profile cut. Matter of fact, if I keep those in there, it's going to make my life a little bit harder, and it'll make Fusion a little bit harder to work with when it's calculating all the different constraints that you have to put in for your tool pathing. So I don't want that. This is good to visualize and make sure it's something I actually want to make. But in machining, I don't need that. Matter of fact, my machine operations already account for, actually, let me delete this one. It already accounts for my puzzle pieces that I want to have. So these puzzle pieces, and these right now are only 0.75. I have to add an additional inch to these. So we won't use this, but what we're going to do is I'm going to right click, and I'm going to copy this entire folder, and I'm going to go back to bodies, and I'm going to paste this thing back in. I'm just going to duplicate everything. We'll hit OK on that. I'm going to hide all those. Yeah, I can't do that. I completely forgot that I cut that profile in. So all these puzzle pieces are basically unmachinable. How I'm going to do this. So actually, I'm going to delete that box, or the all of those the additional copies that I made. These puzzle pieces, what I'm going to do is I'm just going to increase these by an inch. And we'll add an inch of material on this. Join. Okay, so these puzzle pieces are aligned to where I can bring in an 1/8 inch bit. And realistically, and I didn't do this at the time because I used this file, um, that SVG for the puzzle pieces. I don't have a deep enough um, bit to go an inch and 3/4, right? The most I can get out of this is like 0.8 for this bit. So technically, I would need a 1/4 inch bit that's long enough, which I have. I have a 2 inch worth of flute to get all the way down to that pocket to machine all this stuff out. Um, for this exercise, I'm going to keep it at an 1/8 inch bit, and I'm going to modify my tool in my tool database to be able to account for the entirety of the 2 inches of flute needed to actually cut this thing out. If I didn't have an eighth inch bit that was 2 inches long, which they don't make, I don't think they would survive the cut. You'd probably break that bit in half. What I can do is I can scale this entire drawing and get it to where a 1/4 inch bit could get in here and cut these radiuses out. Because right now, a 1/4 inch bit is not going to do that the way it sits today in this drawing. All right, so with that as a fact, we'll go ahead and modify this bit to account for this cut. So I just went into the manufacturing portion, and I'm going to bring up my tool database library and pull this into the middle of the screen. And this 1/8 inch bit, I'm going to right click, I'm going to edit this tool. And, you know, the Armana tool database that I downloaded for this, you know, this is all inputs from the manufacturer into this software. All the cutter, all the different lengths, the flutes, all that really cool stuff. So the overall length of this Armana bit is 2 inches, 2.5 inches. What I'm going to do is I'm going to increase this to 2.25 for the shoulder length. And then I'm going to increase the flute length by 2.25. Length below holder will be 0.25. Must be greater or equal to the shoulder length. What? Oh, I see. This should be 0.225. All right. That gave me a very, very long 1/8 inch bit that will cut this thing out. This wouldn't work in real life to be 100%. This thing would snap right in half. But for this, it's okay. So I'm going to make sure that tool is selected. Cutting speed's good. Again, this is all defaults from the manufacturer. Coolant is always defaulted. I'm just going to disable it. And I'm going to clear all this stuff out. So from here, and actually, before I even get started, I need to correct my actual settings. So the material that I have is set to be 0.75. I can't do that. So I'm going to go ahead and let's delete all this. I'm going to select all these bodies. And for my stock, I'm going to do relative box size with no additional offsets for top or bottom. So that gives me my 1.75 inch, and then this will give me my overall stock width of a little over 8.25 or 8 1/8, and then a little over just under 4.25 for my width. For the setup, we'll make sure that my center point is where I'm going to zero. So this material that I end up putting in the machine will be zeroed right in the middle of it. So when I measure everything, I'll do the diagonal way with my ruler, and I'll mark that actual center point of my material. The material that I put in the machine will probably end up being probably 8.5 by probably 4.75. Will probably be my overall board that I put in. And as long as I hit the center point of that material, I am 100% good with any kind of work holding strategy or anything like that. I don't pay a whole lot of attention to this. The only thing I want to make sure is I overbuild or just make sure I have enough width for my base material that I put in the machine. So all of that's good. We'll hit okay on that. And just to prove that the material that I'm working with is 100% within the parameters of the things that I'm going to cut out. So now from here, I'm going to do a 2D contour, and I'm going to select all the bottoms of these puzzle pieces. And I'm going to do them in order. And the order that I click these on will be the order of how the machine cuts everything out. Height's all good. All right, so I'm going to change this to the right compensation for conventional milling. Multiple depths. I'm going to do, since this is a 1/8 inch bit, I don't want to go any more than 1/8 of an inch. So I'm going to go, well, let's just go 0.25 or 0.2, that's fine. And then I'm going to do a finish only at final. And what this is going to do is it's going to drag that bit all the way at the bottom for its last pass and use the entire edge of all those flutes to go all the way around those puzzle pieces. So that's good. That's good. I don't want to leave any stock, either positive or negative, so that needs to stay unchecked. But what I'm going to do is I'm going to check smoothing. And some of these vertices that kind of have a really, defined curvature, smoothing will make sure that if there's any kind of nodes or anything crazy in this where the machine will jump, that will take that out, and it'll smooth that line out, and it will be very, very smooth and very defined curvature instead of jumping around. So I always check that. Tolerances are always default. I've never had an issue with that portion of it. So that, and I think we're good. I'm gonna do that's fine. And then lead in exit is good. And then I'm gonna set my preferred lead ins to the corners of these. So when my bit comes down, it's gonna come down on this corner for every single one of them. And then it will do the normal lead in and transitions based on these parameters. So, but I want to make sure that these points are all accounted for. All right, that's good. I'm going to okay on that. And then it should generate this file. And right now, inch and 7, yeah, 1.75 inches, roughly 8 passes, about 20 minutes on the bottom here. All right. Let's delete this. So that's good. Now we'll do the same thing for this one. I'm going to adjust this stock. No additional. My stock point is going to be in the middle just to verify. Okay on that. And then we'll use this tool. These are already highlighted, which is good. I'm going to adjust this to 0.2. Pretty aggressive for the step down, even with an 1/8 inch bit. I don't usually ever go past the overall dimension of the bit. So that's why it was 0.125. But for this, we'll leave it at 0.2. And then my points are, let's redo them. So we use these corners. Hit OK. Let this generate. And that's the tool path for this one. So what I can do is I'll go ahead and simulate this just to have a warm fuzzy that I'm good. And then we'll actually cut it out. I don't see anything crazy. Um, slow this way down. It's kind of comical how long that bit is. And then it'll cut everything down and all those puzzle pieces will be cut out. So, which is great. So when I cut everything out, I'm going to put everything together. Let me just pull these things up really quick. When all these cut out like this, right? I'm going to put everything together and I'm going to put it into a jig. This jig is going to crunch everything and hold everything extremely tight to where none of this will move. And it'll be the all, 4 rows of all the puzzle pieces. When I put this back into the machine, I consider this, even though it's 16 pieces, I consider this one piece now when I get everything in. So in the machine, all 16 pieces, it is a solid block of wood. When I program Fusion to cut the 3D profiles and the rest of it, it is all one piece of material. So as long as I have all of this cut out, I am 100% known that I will have a solid block of wood. So my solid block of wood profile that I want to work off now would be this profile. This profile that I cut everything out, all the puzzle pieces out for that one profile. So now what I can do is I can just use all of this and start building my tool paths directly off of this model. So I'll go back into manufacturer and I'm going to do a new setup. Let's do relative size box, no additional stock, right? And this basically says that my stock height of the overall stock that I want, when it's all cut out, is going to be 1.71868. No, you're good, Mark. This was ad hoc. I thought about it this morning and I was like, you know what, let me just do a trial run and bring some stuff up on what I wanted to make over the next week. So I'm probably going to do this every Sunday. But I want to make sure that I don't conflict with your live stream at once. So I'm probably going to hold the 3 o'clock slot if that's okay. But no, I appreciate you tuning in. Okay, so back into the model. Let's see. Hold on. Maurice has some questions for you on getting. Oh yeah, no, yeah. So I'm using not your specific streaming surface that you use, and I had some issues with it, and I need to talk to you, Mark, about how do I get your application for streaming, because it was a lot smoother than what I'm using right now. Anyways, so more to follow on that. I'll definitely reach out through email. Okay, so since I'm going to cut this profile, this is going to be a dual-sided machining operation. So I'm going to cut the top portion first, and I'm going to cut the bottom portion. And I'm going to do it in that sequence. I do not want to cut the bottom and then cut the top. If I do that, I'm going to be hurting. Well, excuse me, I'm sorry, I said that opposite. I'm going to cut the bottom first and then cut the top. And I'm going to build a very special jig to keep these puzzle pieces all interlinked and secured down with double masking tape and some other pressure. I'm going to walk through that, what that actually is going to look like. Uh, so let's we'll use this, but before I end up doing any machining on this, I'm going to go ahead and copy this, and I'm going to do a reverse side of it. So I'm going to select this body. I'm going to make a copy, and then what I'm going to end up doing is just flipping it, just like this. I'm going to repeat this, and I'm just going to move this thing into location, so it makes it a little bit easier. So essentially, I kept the same parameters. Everything is the same. I made a carbon copy, and I flipped it. So now I have the reverse edge, and then I have the top edge. That's very important when we start going through the double-sided machining and the tool path generation and all that stuff. Okay, now let's go ahead and we'll go back into our manufacturer. And what we're going to do is I'm going to do this bottom first. And let's do, yeah, let's do this. All right. So we'll modify. Let's create a new, actually, before we do that, let's do, what I'm thinking about is the grid pattern that we made for this. I need to make sure that I use the same grid pattern, and this is all nested within this portion. So let's go ahead and go back to the design portion and just we'll copy this grid pattern. Let's save as. No, I won't do that. Easiest way to do this is we're going to move this directly over the top, which is good. Okay, that's good. We can hide that, and we'll work with this nose. I'm going to call it a nose. Okay, let's go back to our setup. We'll do relative. We'll add no additional stock. Our body is good, and we're going to click OK on that. There's one more thing that we have to add to this. And that is, actually, if we'll actually hit this. With this copy, I'm going to have to drill, before I forget, these holes need to be drilled into this. Yep. So what I'm going to do is I'm going to save this drawing, and then I'm going to re-import it into Fusion. I got kind of ahead of myself. Some of these features I got to make sure actually gets added into it. Let's do base hole. Desktop is fine. Okay. So what we can do now is we'll hide all this. I'm going to insert that drawing that I just exported. Base hole. I'm going to select this plane. And then I'm going to bring it up. Oh. Let's try that again. Let's hide this. Let's re-import. This will make sense once I get this thing ready. And you don't want to go any higher than that. Okay, got it. That's fine. Interesting. Oh, yeah, my fusion's starting to act up. Yep, that's okay. Let's see if this will actually work. Yeah, it's not gonna work. So the thing that Fusion is so crazy about is it doesn't let you copy or paste any drawings in. So you have to export them out and then import them back in if you want to put them on a different plane. So I technically don't want to remake this, um, which is fine. So what I can actually do, the cheating way of doing this, which I wasn't doing, is let me just build a new offset plane. I'm going to put it all the way on top. And then I'm going to create a new drawing on this plane. I'm going to unhide the that base with the circles. And then what I'm going to do is I'm going to project these circles onto the new drawing that I just made on that plane that's all the way above it. I'm going to hit OK on that. And when I hide this, now I'm working off of the plane that I have, the original drawing. So I can actually hide that. And let me bring the new sketch in. And since it's all centered, I'm just going to go ahead and I'm going to extrude these downwards. And this will give me what I'm looking for. 1.36. So I said 37 or it was like 0.375. We'll go 4. So there's my holes. So that's the bottom of the side of that panel. All right, now we can go back into manufacture. And now my holes are there for me to drill. So with this, let's go ahead and let's do a clearing operation because this is a lot of material that needs to get chucked out. Let's use a 1/4 inch bit. So I'll end up using Armana. Let's see, this is 46202. This is a really good bit, and it's really fast, and it will chuck all of that material right out. So that is 46202, and we'll look that up in the Armana local library, and there it is. So there's my bit. Let's go ahead, and that's way too fast. This needs to be 90. And that automatically changes all my lead in, lead outs, all the other things. 18,000 RPM is still good, but 180 is way too fast for my belt-driven system. Okay, so I'm going to do a bounding box to keep the tool inside this area. And then it's going to cut everything else out. So that's the only thing I have to do with that. For the passes, let's do, I'm going to leave a little stock, 0.02. That way I still have meat for my ball nose. I won't be gouging into anything. So let's go ahead and the maximum roughing step down, let's go ahead and put that to 0.2. So what that'll do is it won't go past that 0.2 as it plunges into the material. That's the only thing we need to change. And I'm going to change my ramp to plunge. Everything else is defaulted. I didn't have to change anything. Everything was good. So I'm going to hit OK on that. Then it's going to generate this tool path. And what it ended up doing is it drilled those holes already automatically. So it accounted for that. And let's just, for giggles, let's simulate this and make sure those holes were actually good. But again, those holes are still at 0.25, or it's still left stock 0.02. So those technically aren't within the parameters that I wanted for the dowels to go into that base. So I ended up drilling it 0.373, which I don't want. So what we're going to do is we're going to go back in and fix that. All right. So that's the tool path. That's the material that it ate out. I don't know why it left this ridge. That doesn't make any sense. Let's go back. Let's double check this. Why did you do that? Yeah. Let's do this. Let's try that. Nope. I don't want resting machine on. Don't have to do any of that. It's probably because of that 0.02, but that doesn't make any sense. I'll have to check in on that. Maybe I need to, maybe because it's centered. So I can keep the tool outside of the boundary. So let's do this. So let's see if that corrected it. Nope. Interesting. Even though this is 0.2, maybe 0.25, extra material that it didn't hog out, which it should have. I'm not sure why it's doing that. Let's do model. No, it's still doing it. If I was to restart my computer, it would probably take that out. I think that's an error right now on Fusion. It just needs a restart to overcome that. You would be surprised on how many restarts Fusion does. It's the name of the game. So we can leave it. But now what I want to do is I want to make sure that I hit my tolerance for the overall dimensions of these pockets. So I'm going to use the same tool, and I'm going to go ahead and I'm going to machine these pockets one more time. I'm going to use the same tool, just those 4 pockets. And then I'm going to uncheck the stock to leave. So it's going to cut exactly 0.375 for the diameter of those holes. I can change this to right. It's fine. It really doesn't matter. I'm going to change this to plunge. And I'm going to hit OK on that. So the tool path is going to be, it's just going to drill, and it's going to make sure that those are in tolerance for the 1 point or the 0.375. Let me double check. And there's some, it's to note, what ended up happening is it didn't account for any of this material already gone. That's what resting machine is for. So if I was to hit resting machine, it would take the original thickness of the material, and it would account for this tool path. If it's unchecked, it doesn't account for any of that. So if I was to change this, and because I didn't put any multiple depths in, if I click that and say I want to go down every 0.25, let's say zero point 0.2, if I hit OK on that and I don't have resting machine on, it's going to think that there's material. And now I got, 1, 2, 3, 4, 5, 6, 7 passes to drill that hole. If I go back in here and I click resting machine, it's weird, and hit OK, it should account for it. And right now it's not. Give me 1 second. I'm going to hide this warning. Let me rerun this without it. Now, let me rerun. Let's do 0.125. For the tool diameter, now it should account for it. Oh, yeah, I need to restart. Fusion. It's okay. I'm going to go ahead and take these passes off. But the concept is true. So resting machine, if it's checked, it accounts for all the material that was eaten by your last tool path. And if it's unchecked, it won't take that into account, and it will still think that there's material there. So let me hit OK on that. And so what I'm going to do is I'm going to highlight both these tool paths. And I'm going to right click. I'm going to post process. And you can't do this with the free version, but for the paid version, I can combine these. Since these are the same tools, it will put it under one tool path. So it'll just be one file, and it will cut both these out. And then I would just post it normally. It would just get included. Right now, what I'll do is I'm just going to go ahead and I'm going to lock these or protect them. Basically, locking those tool paths to say these are good to go. And whatever I do to the model now, it won't account for any of that stuff. So I'm going to go ahead and I'm going to go back to design. And this extrude for these buttons, I'm going to go ahead and I'm going to suppress that. Meaning that they were never there in the first place. But in my tool paths, it still accounts for them. It's still there. And the only reason why I do that is because I don't want my 3D ball nose to go into those crevices and do anything to those holes. Those holes are good to go, and I don't want it to mess with any of that. So now what I can do is I just go to a parallel, and I can highlight. I can select my 3D tool, which will be this. We'll do 100 for my feed rate. For the boundary, I'm going to select this bounding box. And then I'm going to do it all in one pass because I already know that all this material is gone. And I'm going to keep the tool down, minimum retract, and I'm going to hit OK. So about a 30-minute. I didn't adjust. I left the defaults for the step over. Matter of fact, I'm going to go ahead and decrease that. And I can do that in the passes. And I'm going to do this as 0.1. So I'm going to decrease that. Rerun it. Adds about another 15 minutes in, but that 15 minutes and these step overs are so close to each other that there's really no sanding that you have to do, or you'll have to do like a little bit of finalized sanding, but you won't be sanding off any machine marks. And then what you noticed is it didn't cut or didn't do anything to that hole. Um, so that's the bottom side. So this is good to go. I can post this process, and when it's time, um, I'll it's a completely separate file. What I need to do though is I need to make a jig. So when this thing sits and I flip this thing over to machine this side, to make sure that these puzzle pieces, again, they're all interlinked. I don't want them to move. I need to flip this upside down and I need to basically glue it to a substrate. So the jig is this reverse image and it's all supporting itself and nothing should move. So I'm gonna like later on, probably Monday or Tuesday, I'll make a jig that has this profile cut into it. So when I do flip it, it's just gonna sit right in the same spot and it will be fully supported to make sure none of those puzzle pieces move. Um, but before I do any of that, I almost forgot to cut the lines in. So to do that, let's go ahead and we'll bring up this sketch. Not this one. I'm going to move this up. Sketch objects. I'm going to select this. Just going to make sure this is above. The best way to do this. Yeah. I'm going to edit this and bring this a little bit higher. And all that is just is sitting just a little bit above it. All right. So let's go ahead and what we're going to do is we're going to V-carve this into this base feature. So let's go ahead and we'll use the project tool. And I think, I have a couple videos on this that go pretty in depth on how to actually do this. I'm going to hide this plane and get this thing kind of cleaned up again. And then what I'm going to do is I'm going to project this sketch onto this surface to V-carve it. So we'll use the project tool. Let's see, what do I have loaded in? I have 15-degree quarter-inch V bed. Yep, 30 degrees. It's perfect. All right, so let's go ahead and we'll disable that. The speeds are good. Machine boundary, let's use this box. And then for the curve selection, we're going to drop this little caret down and we're going to go to sketch profile. And then what I'm going to do is I'm going to go through my browser tree and I'm going to find this sketch. I'm going to click on it. And that should be good. So now all of these sketch profiles are highlighted. So that means this profile is good for the sketch. It's going to cut all of these lines out. And then it's going to be bounded in between this box. For the passes, let's go a negative 0.04. I don't have to do multiple deaths because it's such a small cut that it's not going down that far at all. We'll keep this as minimum retract and then we'll hit OK. All right. So let's go ahead and we'll hide the sketch. We'll hide this body. And then we'll be able to see that it followed that contour of the bottom. So all those lines are good. And again, these lines are all symmetrical. They're all equal. And they'll all equal depending on how you flip for the dual sided. They will all equal the same because you're using the same zero for your top cut. So the bottom lines will match up with the top lines on the profile that you cut on the bottom and the top. Very, very important. if you cut these wrong, or if your zero is off just a little bit, you're going to notice it. You're going to notice it really, really fast. But the V carve is done. It followed the contours. And now what we can do is we can do the top. But again, I'm going to make a jig for this profile to sit onto so I can cut the rest of this profile out. Okay, so with that, this entire toolpath's done. I can post process. Those are good to go. So as of right now, I have all the puzzle pieces cut out. They're all put together. I've cut the bottom of the profile out, and now we'll cut out the top profile. And what we'll do is we'll unhide not this one, not this one, not this one, but this one. Okay. And we will create a new setup. We'll use relative without any additional stock. So it's basically the same thing, except it's just pointed correctly. From here, I'll redo my 0 point, and my Z, X, and Y axis are all pointing the same. And I'm going to hit OK on that. So from here, this is not a big crevice, but I'll still program the cuts to do this. Now I can go up here and redo all of this again with the pocket clearing, or I can come into my browser tree and the previous one that I made to do the bottom side, I can go ahead and copy that and I can paste it into this workflow. I'll still have to edit this. So let's go ahead. We're going to unsuppress because that's it. It copied it over that way. But what I'm going to do is I'm just going to double click. It has my tool in there. It has all my correct speeds and feeds that I adjusted. I can go into geometry now, and I'm going to go ahead and just select this boundary. I'm going to delete this model check mark. I don't need that anymore. And then here, all of this stays the same. The stock to leave is still the same. The maximum roughing step down is still 0.2, which is perfect. And then for linking, all of this stays the same. I'm just going to hit OK. Very fast way of just getting it back to something that you modified to work for a previous one, and you can just copy and paste it right into your next your setup. Now, the lifting retract, that's a setting issue that I have with Fusion on my computer right now. I'm just going to ignore that. We'll hide that. I'll do that off camera. Okay, so green check marks all the way around. I'm going to hide this. Bring that back in so it's a little bit cleaner. And then what I'm going to do is I'm going to go back into this other profile, and I'm going to copy this parallel. I'm going to hit Control C, and then I'm going to come in and I'm going to paste it into this setup. So from here, I'm going to delete that boundary block, or the boundary machining boundary, and I'm going to select this top portion. I don't have to change anything other than that, and it will give me all the same settings, everything that I had for my prior cuts, and I'm just going to hit OK. And that gives me all the toolpath generation to do that. It's again about 43 minutes for the travel time. And now what we'll do is we'll copy, again, Control C on the V carve, and I'm going to paste it into this setup. Paste. I'm going to open that back up. I'm going to go in, like, again, the same tool was brought over. The same Profile sketch is still there. Everything is the same. What I'm going to do though is I'm going to delete this boundary box. I don't need that. Oop. All right, so boundary, we'll do this selection. We'll find that sketch again. Yeah. Curve selections, we'll select this sketch. We'll hit OK. Well, let's just make sure everything else is good. Good, and good. Now we'll hit OK. And then what it's going to do is just going to do the same machining operation. All the parameters are the same. The depth of cut, the line thickness is all the same. So the bottom lines will be the same thickness as the top lines. And we should be 100% good to go. All right. And it looks like we are. So there's the top portion. And then after that, it's done. I have all the toolpath generations to cut the puzzle pieces out. I have the bottom of the dual-sided machining done. And then the top portion is done. So when it's all said and done, even though you can't see the individual puzzle cuts, it will end up looking like this when it's all said and done. The only thing that is missing is the grid patterns, and I could put that in if I wanted to. I'm not going to do that right now, though. But yeah, that's it. That's a typical workflow of doing multiple different bits into dual-sided machining and different strategies on getting other things to click in, get cinched in, and actually machined. So I'm probably going to do a little bit of work tonight, but again, like that was the whole purpose of the live stream, was just to visualize how I do some of my designing, and again, if I can answer any questions, great, and then we'll just keep going from there. So this will be definitely a next video, and I'll see if I can get these tolerances to actually click these things together. So did anybody have any questions or comments or anything that I can do to help improve this entire process? I'll probably revisit the live stream, and we'll just go from there. So yeah. Yep. Yeah, they're definitely unsupported. And so the tolerances just have to be a little bit tighter, and not much, but the majority, if you can get it tight to where you can actually slide them in together, the weight will bind them together and they won't move. It's almost a fact. So if they're too loose, they'll fall apart. All right. Hey, with that, what I'll do is I'll end the live stream. And hey, Brooks and anybody else that stuck in there, I really appreciate you guys. And yeah, look forward to posting this next project. All right, guys. Hey, happy Sunday, and I'll see you next week. Oh, hold on. Tapered carve. Yeah, I could do a tapered carve. I thought about that actually. I have a couple ball nose that have a slight degree to them that are tapered. I'm not sure yet. I have to do a little bit of thinking in how I'm going to do that. But definitely a way to doing it. All right. Well, hey, happy Sunday, and I'll see you guys next week. All right. Cheers.